Good morning, ladies and gentlemen. Welcome back to your SAT Math Prep Group. This week's topic is geometry. Remember that I really need you to correctly write your first and last name on the name line, and I need you to identify your teacher and your class by circling them in the list. Remember, if you're in more than one class, feel free to circle more than one teacher, more than one class. So this week we are going over more geometry style problems from the SAT. We're doing this so that we can get a little bit more practice seeing SAT style questions, and so that we can practice our other skills like time management specifically. When we get to the worksheet, we will want to make sure that we don't allow ourselves to get stuck and that we practice answering as many of the questions in the time allowed as we have, and more specifically that we work on making sure that we have read every question. Okay, it's very important that you see every question on the SAT because you might know how to do some of them, and you can't allow yourself to get stuck on the ones you don't know. So starting here with example 1, it says in the figure below, two sides of a triangle are extended. What is the value of x? Now this is a relatively rare SAT style question that only requires one step to do. We should recognize, hopefully, that we have here an exterior angle. And an exterior angle theorem says that if we have a side of a triangle that has been extended to form an exterior angle, that angle is equal to the sum of the two remote interior angles. So we would be looking at this picture and trying to recognize that the exterior angle, which would be the x, is equal to the sum of the two non-adjacent interior angles, the remote interior angles, which would be 50 and 70. So we should have the equation that x equals 70 plus 50, which would be 120 degrees. And that gets us there in one step. Now we could also recognize that the third angle of this triangle has to be 180 minus 70 minus 50, which would allow us to do it in two steps. But again, with time being an issue, we want to get it done as quickly as we can. Now if we do it that way, if we do it so that we recognize that this angle right here has to be 180 minus 70 minus 50, that would give us that angle is a 60 degree angle, and then we could do the same thing using a linear pair. X plus 60 is equal to 180, which means that we get x is 120. And that would be an equally effective way to get to the same answer. Okay? It's just a two-step approach instead of a one-step approach. There are often more than one way to do an SAT-style question. So even if you don't think of it the same way as your neighbor, you may still get the correct answer. All right, on to example number 2. Now, example number 2 is a more traditional SAT-style question with more than one step. So I'm going to go ahead and read it before I move on and slide it up to give people that are still writing stuff down from the previous example a chance. In the figure below, lines M and N are parallel lines. What is the value of B? So when we go to do this problem, our first step should be to consider that if those lines are parallel, that tells us something about the left side of this picture. Because now we have a pair of parallel lines, M and N, and we have a transversal K, which means that we know that these two angles are consecutive interior angles. So if we do that, we can figure out the value of A. And we need the value of A in order to find the value of B. That's why this is this two-step equation. So the first step 1, we're going to find A. And to do that, we're going to use consecutive interior angle theorem, which says if two parallel lines are cut by a transversal, then the sum of the two consecutive interior angles, there we go, I managed to get that out, must add up to 180 degrees. They must be supplementary angles. We would then be able to solve that one-step equation to figure out that A has a value of 50. Which means that this angle here is 50 degrees, and so is this one. This angle is also 50 degrees. Now the other thing we have to recognize is that because L and M are perpendicular, this angle here is also a 90 degree angle. And then we can focus in on this right triangle that's formed by lines L, J, and M. So if we look at just that triangle and not the rest of the picture, we should notice that we know that this is a 90-degree angle here, and that A is 50, so we know that acute angle, and that just leaves the angle marked B, which means we can use our angle sum theorem for triangles, which says that every triangle contains 180 degrees worth of interior angles. So B plus 50 plus 90 equals 180. Combine like terms, B plus 140 equals 180, and then subtract 140 from each side, which would give us our answer, B equals 40. Okay. Our final example, example 3, says in the given figure, AC extends to point D. If the measure of angle BAC, so I'll mark that one here with yellow, BAC would be this angle, is equal to the measure of angle BCA, which is this angle, what is the value of x? So that means that triangle ABC is in fact an isosceles triangle because these two angles are the same, they are equal. Now the other thing that we should notice is that we have a linear pair formed by the 110-degree exterior angle and our pink angle, angle BCA. So we should start off finding the measure of angle BCA by saying the measure of angle BCA, again that is our pink angle. So the measure of the pink angle plus the 110 degrees has to equal 180 degrees because they form a linear pair. As such, we can find the measure of that angle by subtracting 110 from each side of the equation, which would give us that the measure of our pink angle, the measure of angle BCA, is 70 degrees, which means so is the measure of angle BAC, because those angles are equal. The pink angle and the yellow angle are both 70 degrees. Now, once we know those two angles, then we can run the angle sum theorem on triangle ABC. X plus 70 plus 70 has to add up to 180 degrees because that's a triangle. Okay, so that triangle ABC adds up to 180 degrees. So the three angles in that triangle have to add up to 180, x plus 70 plus 70. Combine like terms gives us x plus 140 equals 180. And then we would simply subtract 140 from each side of the equation, and we would get our answer that x is equal to 40. Now, at this point, your proctor is going to pass out the skill check. The skill check is a little bit longer this week because we have a little bit more time than we usually do, and also because I want you to practice your time management skills for the SAT. You get between 1 and 2 minutes per question on the SAT. So you do not really have time to be stuck and thinking about any specific problem. So what I'd like you to practice today is go through the worksheet and answer the questions you know how to do immediately the first time through the worksheet. If you get stuck, go to the next question. Once you've gone through all the questions and have read them all and answered the ones you're 100% sure on, then go back and answer the questions that you have to think on. You want to make sure that you get to see every single question on the test. All right, good luck, folks. Make sure you put your name and your teacher's names on both papers. Thank you very much for your time and attention.